Hi everyone, welcome to the video lecture series of Theory of Automata and Formal Languages. We are currently learning the topic regarding Turing Machine. So we have understood a few of the important introductory topics regarding Turing Machine, and in my previous lecture we have seen some of the different types of Turing Machine, you can say variants of Turing Machine, okay, where we have seen multi-tape, multi-tracked and universal Turing Machine. Okay, then we have seen few other types of Turing machines, and if anyone has not viewed or anyone has not listened to that particular topic, you can also view that. Okay, so in this particular video we'll be looking into what are the different types of recognizable languages being recognized by a Turing machine. Okay, generally two types only, but still we'll be looking into some other terminologies as well. Okay, so basically let us start off with the first one, that is a recursive language and recursively enumerable language. These are the two basic important types of recognizable languages for a Turing machine. Okay, so if you talk about recursive language, it's the language. If you talk about any language, suppose L is a language, is said to be a recursive set if and only a Turing machine, suppose if I talk about M as a Turing machine, holds for all W means nothing but all strings, possible strings that belongs to that language L, and definitely rejects whatever strings which are not belonging to that particular language. This is a very important point for understanding what is recursive language. Okay, so if I talk about a recursive language, I can also say like this, that a language L is said to be recursive if there exists a Turing machine. Okay, definitely if there exists a language, there will be always a Turing machine corresponding to that particular language, which will accept all the strings in L and rejects all the strings that are not in L. That is being completely defined by taking a Turing machine M. Okay, halts means it will stop executing as soon as all the strings belonging to that particular language is being accepted. Okay, and rejects when those strings will not be belonging to that particular language. Okay, so if one more thing is that if a language is recursive, then it is always a recursively enumerable language. That means you can think of it that if a language is recursive, then recursively enumerable language will also be a subset of this particular language, correct? So we'll be looking into this recursively enumerable language in the next topic. Okay, now if I talk about the class of recursively languages, or if you talk about the recursive problems we'll be having, one is the acceptable by halting Turing machine. Okay, that means that a Turing machine will halt with an acceptance for all the strings that belongs to that particular language. This is one criteria. And the other one is that the decidable or Turing machine decidable. That means that particular language where the strings are being accepted must always be a decidable scenario. If it is an undecidable, then that completely it will go to an infinite loop, or it won't be halting at any moment. Okay, so that cannot be a scenario. Always the scenario will be a decidable, and the other one will also be always a acceptable. So based on these two scenarios, we can directly clarify that this is a class of a recursive language. Okay, language, or in terms of problems you can say. So this is the general definition of a recursive language. Now coming to the important topic, the second topic, that is known as the recursively enumerable language. That a language L is said to be a recursively enumerable language. A language L, mind my words, a language L is said to be a recursively enumerable language if, on the other hand, there should be a Turing machine which accepts that particular language, where for all the strings belonging to that particular language will get an acceptance. But most important point to be noted is that it may, or the Turing machine may or may not halt for all the strings which are not in L. See there, what was the difference? This is the difference, that for all the strings which belongs to the language L will always halt for both recursive and recursively enumerable language. But in case of the strings which does not belongs to L, in case of recursive language, the Turing machine will directly show reject. But in case of recursively enumerable language, the Turing machine may or may not halt. Okay, it means may not show the rejectance. So this is the small difference between recursive language and recursively enumerable language. That's why this is a very important point that I have told you, that if a language is recursive, then it is always recursively enumerable language. That means recursive becomes a superlative to this particular recursively enumerable language. But on the other hand, if I say that if a language is in recursively enumerable language, then it may or may not be a recursive. Correct? So this is an important difference between these 2 points, these 2 languages. Okay. And as I've already told you, the class of languages acceptable by Turing machine is known as recursively enumerable language. Okay, and the language generated by this is called as the unrestricted grammar. Okay, because the grammar, because generation always depend on the grammatical part. Okay. Now moving to the third one, this is termed as a decidable language. So what is the definition of decidable language? Is that language L is said to be decidable language if it is recursive in nature. If it is recursive in nature. So I can write down the point. So this is what a language L is said to be decidable if it is a recursive language. And definitely all decidable languages are recursively languages and vice versa. Okay, so you can say in terms of a recursive language, this is another name that is nothing but decidable. Already I have given a class of this recursive language, that is an important point, that is decidable. That's why it is also known as a decidable language. Okay, coming to the next point, next language, that is your partially decidable language. Okay, so if I say you that what is mean by partially decidable language, that a language L is said to be partially decidable. See, if you can directly recommend what the name of what it will be. Okay, if I say decidable, then it is a recursive language. If partially decidable, then it will be recursively enumerable language. Correct? So I can note down the point as the language L is partially decidable if L is a recursively enumerable language. Clear? Now moving to the undecidable language, this is like I don't need to say anything about this particular language. You have understood, like decidable means recursive language, partially decidable means recursively enumerable language, and if you talk about undecidable language, then so if I say the undecidable language, that means that a language L which is not decidable, correct? But there is one condition, that if a language is partially decidable, then sometimes it falls in the category of undecidable language also. But if it is a decidable, then it cannot be a language which is undecidable. That means not able to get a solution for that, not solvable, you can say. Okay, so what statement I can note it down? Can say that a language is undecidable if it is not decidable. That's the main point. And an undecidable language may sometimes be partially decidable, which I have already told you, but cannot be a decidable. That means not solvable. Okay. Now finally, how can I conclude this? I can conclude by using a table which will be always useful for you to get a summary of this particular scenario. That a recursive language is, okay, here the Turing machine will always halt. Okay, recursively enumerable language, Turing machine may halt sometimes or may not halt. Okay, this means that for all the strings which belongs to the language, definitely we'll get the accepting halting result. Okay, but the strings which are not belongs to that particular language may halt sometimes or may not halt. Decidable language, as I've already told you, that these are always a recursively language, and partially decidable language are nothing but recursively enumerable language. Undecidable means not solvable. That means no Turing machine for this particular language. So this table I think it will help you a lot in get the summary of all these languages. Okay, so I hope it is clear to everyone, where we have learnt about different types of recognizable languages by Turing machine. One is a recursive language, where the Turing machine will definitely halt and give you an acceptance for all the strings which belongs to that language, and definitely give a rejectance for all the strings which does not belongs to the language. And it is always a decidable language, recursive language. Whereas recursively enumerable language, it's a language which generally accepted by the Turing machine, but for all the scenarios, the Turing machine may halt sometimes or may not halt. Clear? And finally, we are come across with these sub languages, you can say, or other terminologies for these languages. The decidable language, as I've told you, is always a recursive language. Partially decidable language is always a recursively enumerable language. An undecidable language, by the term only you can justify that undecidable language means not decidable, or you are not able to solve. That means there will be no Turing machine for this kind of language. And this is the summary of your entire lecture. Okay, so I hope it is clear to everyone. So in the next video lecture we'll be starting off with the construction of Turing machine, where we will be looking into different types of examples and of the languages, and based on those language we will try to find out how to construct a Turing machine with the help of tape and the tape head. Thank you for watching the video. If you're having any suggestions or comments, please comment down below, and I would suggest that to subscribe my channel to get the updated videos as well. Okay, thank you for watching.